All right, we're back with weekly reading questions number 8. And again, I'm going to put my copyright on this. And this is 30 April 2022. How do snowflakes form? Small ice crystals form onto tiny particles in the atmosphere called freezing nuclei. This is very similar to the way that rain droplets form on cloud condensation nuclei, or how cloud droplets form. So then the primary way that a crystal can grow larger is by, so if you have a crystal, a tiny little crystal here, or maybe even a freezing nuclei that looks like a little chunk of something, then little water vapor molecules will be attracted to it. It's a complicated process, but once that happens, this thing will start to grow into an ice crystal. And as it gets larger and larger and larger, more and more water vapor will accrete onto it, will deposit onto it. Another thing is if the snowflake is falling through particles, water droplets, it'll suck up the water. And also, so the little water droplets can accrete onto this. So there's a number of processes. But the process that talked about in the book was basically these freezing nuclei and the fact that water vapor in the atmosphere or from nearby water droplets are basically help this little nuclei to grow. Okay. So the book explains the phase diagram in figure 6.2 and points out that the relevant phase change is between gas, here the H2O, and the solid phase. So this is a gas to solid when you're building a little ice crystal. Okay, second question. What is permafrost? Permafrost is permanently frozen ground. And that's ground that remains below freezing, so below 0 degrees Celsius for 2 years or more. And there's quite a bit of this in Siberia and in Alaska. Why might melting permafrost be important for future climate change? It's because methane-producing organisms may thrive and release methane gas into the atmosphere. So if you got a piece of permafrost here down below, this is basically frozen permafrost. And if it starts to melt, it's going to start to give off methane, which we know is a potent greenhouse gas. So this is a positive feedback cycle. That's why it could be important and detrimental for future climate change. Explain the difference between the way glaciers and sea ice accumulate ice. Glaciers accumulate ice in their accumulation zone, where the temperatures are cold enough that snow persists all year. And glaciers also accumulate snow from the top down. So if you've got some ground here and you've got a glacier on it, snowflakes are falling onto that in the winter in the accumulation zone and forming this glacier that might be lying on top of the ground here. On the other hand, sea ice accumulates ice from the on the bottom of it. So if this is the ocean surface and you've got a piece of ice that's just starting to grow here, it's going to grow by water freezing onto the bottom of it and making it thicker. So really this is a top down and this is a bottom up. This is sea ice grows from the bottom up. Explain the difference what role, I'm on number 5 now, what role do oceans play in the distribution of sea ice? The Arctic Ocean is almost completely surrounded by land. However, warm currents, both the North Atlantic Drift Current and the Kuroshio Current over by Japan, over by Asia, inhibit sea ice growth in the kind of the eastern margins of the North Atlantic and the North Pacific. So that's one way that ocean currents in the north play a big role in distribution of sea ice. Also, sea ice in the Arctic kind of flows from over off the coast of Alaska over to Greenland and out Fram Strait into the North Atlantic. So the sea ice kind of moves with ocean currents in the Arctic. On the other hand, the strong winds and the surface currents around 60-degree latitude around Antarctica help to prevent sea ice growing more, because the winds kind of break up the sea ice and the warm currents don't allow it to form. So if you remember, Antarctica is kind of a big circle here, and the sea ice kind of grows around it. But at about 60 south, it's too warm out here and too windy. Too warm and too windy for the sea ice to grow much beyond about 60 degrees south. And then finally, what are the two primary ways that sea ice affects climate? Well, we talked about ice albedo feedback. And this is when it warms up, you melt sea ice, and then it makes the Earth's albedo go down, which makes it warm even further. And then also the ocean heat flux feedback, which is shown in ocean heat flux feedback, which is shown in figure 6-2. 6-2. Or I'm sorry, 6-12 in the textbook, and explains how that happens. That basically when you remove sea ice, you have a greater flux of the warmer ocean below has a large flux out of the ocean that otherwise you wouldn't have when the sea ice insulates it. Okay, that's it for chapter 8.